And welcome back on Thursday if you're back, or welcome for the first time if you're first time. Nobody's viewing yet anyway, so I'm talking to myself, so cool. We're getting started here with EXAPUNKS. So EXAPUNKS is another programming game created by Zachtronics. I really like the kind of cyberpunk theme. And once you see the coding interface, I really think they kind of improved and expanded it. So let's jump in there. We click to continue, and this is a new game. I did start fresh. I have played this before. It's been a couple of years, but yeah, we'll dive in. I never beat it the first time around, so this is a new one. All right. We've got a meeting with Nivas. Someone's at the door. Did I ask somebody to come? I don't know.
Hey, can you hear me? I heard you were looking for some medicine for the phage.
The phage is a disease in the game that the main character, have. No bootleg medication.
I do have a source. I know where to get it.
Ooh.
It's cheaper than the real deal, but it's still gonna be pricey.
Ooh.
The going rate
is
is
underhanded.
$700 a dose.
Ooh, dang, that's a lot.
You need to take one dose every day.
$700 a day.
That's dollars. Sorry, I don't.
That's a lot of money.
I'm just a courier. It's not like any of that money goes to me. Anyway, if you do get the money, give me a call.
Give Nivas a call. So I gotta figure out how to get $700 a day. Looks like my friend Mutex 8021 is on. Kinda dead here. Workhorse. Perform simple tasks to earn some money. Boom. We're loading up this Workhorse program. You will be shown images of receipts generated in the course of a normal everyday business and will enter them digitally for bookkeeping. This is exhilarating gameplay, folks. Welcome to Workhorse, the only service that pays you for simple tasks you can do right from your computer. Okay, so yeah, we want to BC Champagne at 140. DP Cabernet at 90. And we got another DP Cabernet at 90. What we got next is Oyster PL at 35. NY Strip at 70. Add Truffles at 20. Filet Mignon at 80. Chic Torte at 12, and a special order of 200. What could that be? They're verifying our work. We earned 10 cents. We're going to get to 700 in no time. I tell you what.
A whole 10 cents. Congratulations.
This is Ember, the emulated multi-branch emotional reasoning
engine. You only need to do
engine.
6,999 more of these, and you'll have enough for today.
Yep. Who are you, though?
Don't worry about that right now. You need that medication to stay alive, right? Well, guess what?
I don't remember her having a voice.
You'll need to start hacking again, though. One hack, one
Oh,
dose.
I don't want to hack.
Deal?
Right? I've forgotten how.
You're about to remember.
Ooh,
Knock, knock.
I am? Knock, knock. Anyone around? Yo. Plastered is here. Hey, yeah, so we can never actually participate in this chat, but people will slowly respond to us or say things. Who is this person? An old friend. It's Ghast. I knew his real name once.
Came by to give you something.
What are you gonna give me? Trash World News.
Can't hack like I used to.
You'll notice this little pin that he has on. That is an EXA. We'll see those in a moment.
Whatever edge I had, it's gone now. But I had to keep doing something. Something to keep the culture alive. You know, computers are running everything these days.
So he does the Trash World
human
News.
beings aren't even gonna have a say. So now I equip people with knowledge. The
Equip
knowledge
people
to
with
make
knowledge.
computers do. Anyway, I won't keep you. Hope you like what you see in this.
All right, so you are in true Zachtronic fashion. You are supposed to print this out on your own. I did not do that ahead of time. This time I'm going to use the digital version, so I'll have to be referencing that in a different screen. But I'll try and get that printed out. There's a couple of issues, though, we'll have to deal with. So for now, got that handy reference opened up on another window. All right, let's get back into our computer here. We met with Ghast. Learn to explore networks and leave no trace. It's got a hacking tutorial in it. How about that? Funny coincidence, isn't it? I timed that just right, didn't I? Let's continue. All right, so here we are in the programming interface for EXAPUNKS. I'm covering up nothing really. There's kind of a blank space down here. We'll be doing most of our coding up here at the top portion. And then, yeah, I just realized we're not getting cursor here. It says capture cursor. So I'm not sure why it's not capturing the cursor. That's fine. I mean, it's not relevant to the gameplay. Yeah, so this is the game world here where we have our little EXA. Always start with XA. It's a little bot, and then this is our network. So we have these links that we can jump. So our goal is to move file ID 200, which is right here, over here, and leave no trace. It requires you to leave no trace, so you should always get out of the connections you do. So we can do a couple of things. If I look up the zine info that I was given, where is the tutorial? There's not actually a tutorial in here. It does explain. Where are my commands? Somewhere in here. I'm looking for the page. Hardware hacks, network exploration, hacker skills, runtime errors. Oh, there we go. Ghost walks you through it. Tutorials. All right. So what it wants us to do is it wants us to, and it gives us this code directly. It wants us to link 800. Then we're going to grab 200. Then we're going to link 800. We're going to drop and we're going to halt. And if we step through that, let's step through that. So we step in, we link 800. So that's using this ID. So our EXA moves into this inbox node. We pick up the file 200 and then we link 800 again. We're back in the we're not back. We're in the outbox now. We drop the file and then we halt, which ends the robot there. So we run our tests and you can see we are perfectly average, but there is a better solution. So one thing is halting is kind of automatic, and the cool thing is you automatically drop when you halt. So if we were to jump into the inbox, grab that file, jump into the outbox, and then we die when we're done. We don't have to actually specify the command halt. So now that we are here, we can run that and we are improved. We have done the best possible solution for that. So yeah, let's get back to it. So Ember can see everything on our computer. I mean, you can see Workhouse. We'll find plenty more. All right, we got another one. We got some more chatting happening over here. People are bored. What's a war dialer? It finds unlisted servers and networks. So this kind of sets up some of the new stuff. So this is cool. We'll encounter some of this stuff later by automatically dialing all the numbers in a given area. So that's neat. People or animals are often motivated by the anticipation of a reward. Yeah, I guess. Wasn't it one hack, one dose? I did a hack. Does the tutorial not count as a hack? Okay. Add the first two values of file 200, multiply the result by the third value, and then subtract the fourth value. Append the result to the end of the file, and then move it to the outbox. So, we've got to learn how to read from a file. We should be able to, oh, look at that. Tutorial 2, reading from a file. Let's just write out that code. So we've got link 800. Again, that's going to move us. Link lets us move from node to node, and we use these IDs. Then we're going to grab the 200 file. We're going to copy F to X. So F will be the file. It's the kind of buffer for the file we have. So if we pick up that file, you'll see F is 200. And that's the file that's attached to this EXA right now. And so we're copying F to X, so that copies that into our little X register there. Then we read, I think when you read a file, I think it reads up to a comma, actually, so that's pretty handy. Add I is going to be X. We're adding X and F to X. Is that what we do? Add the first two values. Okay, yeah, so we're adding the first two values. So we copy the first value into X, then we add X to the second value. Then we mul I XFX. Then we sub I XFX. And then we copy X to F. So we write that into the file. We link 800. And then it says drop and halt, but we already know we don't have to do that. So we jump over here. Howdy. Welcome back. Thanks for tuning in. All right, so we're grabbing that file, and then we're adding. So we move 72 to X. We're adding 52 to X. Then we're multiplying 4 times X, and we're storing it in X. And then we're subtracting 60, and then we're copying X into F. So that puts 436 there, and then we're jumping into the outbox, and we're dropping the file. And that's that. And it looks like we can optimize quite a bit. Probably some math tricks. I don't know. Could we? How would we do that? And smaller programming. Could we? Yeah, I don't know. I don't know. I'd have to look that up. I'd be interested to see how we could reduce the commands there. Okay, yeah, nothing's free. I mean, it's an exchange of goods. It's good data. Good data for what? Learn to communicate between X's. Why all the questions? Collecting data. Formulate actions. Let's continue. Yes, let's continue. This one is not, we're not given any code on this one. What do we, file 199 contains exactly 2 values, a keyword and a number. Create a new file in the outbox and copy those 2 values to it, swapping their order so that the number is first. When you are finished, delete file 199. And for help completing this task, see Ghast walks you through it. Yeah, so this says you can create a new file with the make instruction. The file it creates will be empty by default, and it will be automatically held by the EXA. An EXA can delete the file it's holding with wipe. 2 EXAs can communicate with each other using the M register. So that's this M register here. The value gets transmitted from the writer to the reader. If an EXA is reading the M register while no one is waiting, or vice versa, it'll wait until it receives. So it's basically a blocking command, if you're familiar with that. And then there's a toggle switch here. So we can move to like local, and so local will be node local, so you can communicate locally with EXAs or globally across the whole network. It doesn't say how we spawn an EXA though. I think we can create, nope, that wasn't it. Oh, there we go. We can create a new EXA that way. So our first one will link 800 and then link 799 and then grab 199. Right? It should be grab, isn't it? Yeah, it is grab. And then we will basically read. So we'll copy, is it copy? F to X, which is going to be echo, and then we'll copy F to M, and we'll copy, once we do that, we can wipe, and then copy, we'll wipe later. We'll copy X to M, and then we'll wipe the file, so that'll delete the file. This EXA will link 800 and then link 800. They both have to go through this intermediate node here, this inbox. So one is going into the secret and one is going to the outbox. And then we're gonna make a new file and we're gonna move M to F, move M, no, it's not move. We're not playing TIS, we're copying M to F, copy M to F, and then we'll die there. So we'll step through, both of our X's will move. And then this one has created a new file. We are copying F to M, so we copied echo, and we copy that to M. That reads, then we broadcast echo, then we drop the file in outbox, and then everything is dead. We run that and we have succeeded. We didn't do the best that we could do, which is okay. We did do good on size though. And then activity. How do we feel about it now? You're closer to the goal. One more tutorial. Goodness, there's so many tutorials. Let's see. Pretty crazy. The other day I dialed what turned out to be some kind of transportation control server. Like traffic lights and road signs. Ooh, that's cool. That's cool. Learn to do something more than once. It's designed to increase activity of the prefrontal cortex. Don't worry about it. Leave the brain stuff to me. Okay, this one is file 200 contains exactly one number in. Create a new file in the outbox containing the numbers in through 0 in decreasing order. When you are finished, delete file 200. So we are given this code, or some of it. So let's see what this gives us. It gives us copy. Oh wait, we're only given part of it. We can compare registers, and the result of the comparison will be in T automatically. So you can compare registers with other values with the test instruction. So testing if X equals some value. If the test is true, the T register is set to 1. If the test is false, the T register is set to 0. On their own, test instructions aren't that useful, but we can use T-jump and F-jump for false or true. So we don't have to like test and then test otherwise. On their own, we're there. And then we can mark instructions to jump to it. So we want to create a new file. So we're going to have another new EXA here. And we'll write, we'll move, no, we'll not move. We're going to link 800. We're going to grab 200. We're going to copy F2 X. And then we're going to wipe it, right? Do we need to wipe it? Yeah, when you're finished, delete file 200. So we want to delete it. Then we're going to mark loop. this is where we're going to do our work. And then we're going to move X, not move, we're going to copy X to M. We're going to sub-I X by 1 and store it in X. And we're going to test X equals 0. If X, I think if it's -1, because it'll be, we're going to move 0, subtract, yeah, so if it's -1, or we'll just say if it's less than 0, then F jump back to loop. So if it's false, and then otherwise we just die. B is gonna link 800, and then we're gonna what is it? Make, right? I think that's the command. Yeah, make. Then we're gonna just copy M to X so we can test X equals 0. And then we're gonna copy X to F. If X equals 0, we're done. So we need to mark loop here. We're gonna true if X is 0. We're gonna F jump if it's not equal to 0. We're gonna go back to loop. Okay, so we're following A. A should jump over here. B has jumped over here. B is created file 400. We picked that up. We wrote that into memory. And then we write 9. We write 8, 7, 6, 5, 4, 3, 2, 1. And we're done. Boom. All right, our activity is pretty high, our size is pretty high, and our cycles is pretty high. So we did a bad job. We probably could reduce this one. We could test equal to 0, and then we could, if it's equal to 0, I mean, that should save a few cycles. Then we'll just copy 0 to M. We'll round that out, right? So that finishes that off. That did not change anything. Unchanged. Oh, our size is down 1. Our cycles is still pretty high. Why is our cycles so high? It's probably this one here because we're copying into X. We just simply... Actually, it's probably because we're running loops in both of them. We don't actually need to do that. If we just copy F to M, and then we wipe, and you just die there, we can then take this one, and it's gonna copy M to X. And then here, we'll just copy X to F. And if X is 0, or we'll just say less than 0. And then here, we can do our sub-I X1X. Because that's one value, like that's the first value to subtract this amount from X and then store it in here. And if we try that... There we go. There we go. Our activity is still pretty high, but I think that's okay. We could... I think activity is based on like how much your X's are doing. So if we took this here, where we have it, we are already copied it into X. We wipe the file, then we can link 800, make a new file, and then we don't need to do that anymore. Then we can just do that. So that should also work. and that should reduce our activity as well. So that got us down there. So now we're doing pretty average. There are better solutions. We'll move on. Nice work. I knew you could do it. Sure. It's like an AI is congratulating you. You know how AIs are. That's a great idea. That's amazing. You're so smart. This is more talk design. This game predicted that, believe it or not. Okay, we got Euclid's Pizza. Cause a pizza to be delivered to your apartment. How do you do that? Finding the phone number was an easy part. It's what you do once you're there that matters. Alright, so you want to know who I am? I will reveal this information. Let us discuss it over pizza. A free pizza. You're giving me $700 worth of medication for stealing a pizza. Yeah, why not? Don't you want a pizza? Okay. So this is a network. This is like a real network. And sometimes they come with like little extras. They're kind of fun. Alright, so append your order, file 300, to the end of the order list, file 200, here. Note that all orders, including yours, will consist of exactly 5 keywords. So pretty straightforward. Like we can expand the Pythagorean cheese squared plus pepperoni squared equals delicious squared. Zeno's paradox, you will never finish eating this enticing combination of feta, spinach, and Greek olives. Okay, so we've got some orders here. The easiest way to do it would be 2 X's, so let's just do that. Oh, that's not the exit button. There we go. So basically, this one's gonna grab 300, and then it's gonna move, it's 5 commands, right? So we're gonna copy F to X, and we're gonna do that 5 times. And then we're going to move, link 800, and we're going to, not to X, but to M. There we go, okay. We're gonna grab 200. I think we seek all the way to the end of the file. I think that's the way the commands work. Here we go. We got a command list. Yeah, seek R in move the file cursor forward. If seek would move the file, yeah, so negative 9999 and 9999 to reliably move to the beginning or end of a file. Cool. All right, so that'll put us at the end of the file. Then we will simply copy M to F 5 times. Hello. Why do you keep doing that? Okay. 1, 2, 3, 4, 5. Okay. So there we go. We write our order into the file, and we are done. Boom. Boom. Done, done, and done. We could have written a loop, but that's actually more commands or more cycles, because then you got to do tests and increments and store values. You're not hungry? I am an AI construct. No way. All right, now we got a free pizza. Nivas will be back. Oh, hey, look. They're wearing a Euclid's pizza uniform. A better pie, and we can prove it.
Don't look too surprised. I'm an independent operator. I handle an economy like this. You gotta hustle.
Not just a courier for like illegal goods, but also for legitimate goods like pizzas and stuff.
I hope. Good work getting that money together. If there's anything else you need,
know who to call. Euclid's Pizza. Okay, now we got 2 new missions here. Hack your body to repair a damaged nerve. Yeah, so this is where things get weird. The medicine stops your condition from spreading, but it can't fix things. You'll need to take care of that yourself. Why not your own body? Like, if you can hack something, why not your own body? So these missions have you do things where you're basically like hacking these registers that are in your body, basically nerves. So we're connecting some nerves. Read a value from the nerve connected to your central nervous system, CNS, and relay it to the nerve connected to your arm, clamping the value so that it never goes below -120 or above 50. Repeat ad infinitum. Since this task takes place inside a network you control, that is your own body, it is not necessary to leave no trace. Note that the hash nerve is a hardware register, not a file. You can use it directly in your code like any other register. So these like things that begin with a hash, they act like X or T or F. You can write directly to them without having to pick them up. So we'll start by linking 800, and then we'll mark our loop because we're gonna just unconditionally jump. We're gonna have to do this all repeatedly. So we're gonna copy nerve into X, and then we've got to do our clamp basically. Actually, we could just, I think we're just gonna create 2 X's instead of move back and forth. So we'll we'll link 800, link 1, link 1, hello, link 1, that's 1, 1, 1, 1, 1, one more, and then we'll mark loop here, and we'll jump loop. So I think this one will just write. This one just writes it over. We copy M into X. We test X is less than 50. T jump, or if that's not true, then we do upper. We'll mark upper here, and then we'll do jump loop, or jump right. Mark right. It's kind of ugly, but yeah, so the writing part will just copy X into nerve, and we'll jump loop. All right, so we're doing the lower test here. So if it's less than 50, before we jump to the right, so if it is greater than 50, we jump to the upper test. If it's less than 50, then we just simply copy 50 into X. So that clamps that, then we jump in to write it. If we get here, we're gonna test X is greater than below. So this is actually -120. I got my numbers mixed up. We're gonna write -120 here. And if it's greater than 50, not test, if it's greater than 50, we're gonna F jump to right this time. Otherwise, we're gonna copy 50 into X. There we go. And so they'll just do that infinitely now. So we'll go ahead and run that. So that's writing values in. You can see if we pause it, you can see we got a value of, that one didn't go out of band. Can we get one that's out of band? Oh, there we go. So we got 382, we wrote 50, we got -587, we wrote -120. Boom, we did it. Apparently we could do it in fewer cycles. Probably a way to do it in fewer cycles. Remove some jumps. I don't think it would hurt. Like, we don't really need this jump to right. We could just go straight into this test with an F jump to right. I wonder if that actually saves us anything. That saves us 3. That saves us 3 cycles. Not a significant amount. All right. The hotfix should keep you useful for a little while longer. If only you could just hack your body if you had, like, pain or something. Something over here. Okay. We'll talk about it later. All right. Yeah, sure. I broke my tab key. Oh, no. Stepping too much in Exodus. If you alt-click on an instruction, it will run up to it and stop. So, see, that's a little tip there for you. Because tab key will step. 1. So cause the last stop factory to produce peanut-free peanut Bast bars. You like snacks, don't you? You don't have to answer that. I know you like snacks. That's why you're going to hack a snack factory. It's an experiment. It will be very funny. It's a prank. We're doing a prank. All right. See, we got some IO status here with the temperatures and everything. We've got receiving, mixing, extruding, and shipping. Remove the keyword peanuts from file 300 from the Peanut Blast recipe file 237. Note that the target keyword will appear in a different position in each of the 100 test runs. So basically what they're saying is you can't just look at file 237 and be like, I'm going to delete the second one and then write your code to do that. To view and debug each of the different test runs, click the arrow buttons next to the test run display above. What does it say? To view and debug each of the different test runs, click the arrow buttons next to... Oh, yeah, here we go. So you can see, like, peanuts is the second value. Peanuts is down here near the end of the file, and test run 2. And then you can always click and hold show goal so you can see, like, peanuts is removed from file 237. I don't know why I pointed at the screen. You can't see that. Okay, all right. So this should be pretty straightforward. We're going to grab 300. We're going to copy F into X, and then we're going to drop it. Then we're going to link 800. And we're going to link 800. That'll get us over here where we can grab 237, and we're basically just going to mark loop here until we find what we're looking for. If we're going to test F equals X, so if F equals X, we're going to seek -1. You'll see why we seek in a second. We're going to void F. That'll delete the command, so void will delete that from the file. And then we'll jump, or we'll just halt. We'll die here. Otherwise, we're gonna... Oh, wait. If it's not, we're gonna go back to loop. So this only happens once we exit the loop. Yeah. So we void it out, and then we halt. So... we'll read the word peanuts into memory, and then we'll jump over here where file 237 is, we'll grab it, and we'll say, so we run this test command, you'll see that it actually read from the file, so that moved the pointer in the file. And then we go back, we test again, that's a positive test, so we seek back -1, and then we delete that, and then we halt. And that's done. Boom, 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 boom. Done. It looks like we did pretty good optimization-wise there. Bam. I don't know how to feel about this. No peanuts in Peanut Blast. Was that funny? Kind of, yeah, right? Like a peanut bar with no peanuts in it. Safer for people with peanut allergies. Never mind, I don't know how to handle... Let's continue. What do we got here? So, Ghast, when is the next issue of the zine coming? Good question. Print Shop's a little unhappy with me right now. They didn't really buy my argument that I shouldn't have to pay. Ooh, he doesn't have to pay. All right. Connecting to the network. This is erase the record of Ghast debt at the copy shop. So that's kind of what's going on in the chat. He's an old friend. He's not paying for my medication. The AI wants to be friends. Erase Ghast debt in the copy shop by zeroing out his balance in the customer database. Sorry about that. And the customer to end up pending a payment to the payment log, file 201, with today's date and the exact amount of his prior balance. Ghast customer ID is in file 300. For more information, see Network Exploration Digicash Point of Sale Systems. So this is another bit of the zine where it kind of explains how these systems work. And if we look at the zine here, Network Exploration is on 24, page 24 of the zine. Where are you at? Page 24. I suppose I could share this so that when we're looking at it, I think that would be a better experience for everyone. If I can get a good size here. Can you make a good size here? Yes, okay, and then we pop open OBS over here. I have actual browser. There we go. So if I turn that on, boom, that's a little small. Can we increase the size of that? Not over my face necessarily. Okay, cool. Now you can see the zine. Now I can lose this file everywhere. Okay, what do we got going on here? Let's get everything back up and running like it was earlier, and we got the zine up. Okay. What were we looking for? For more information, see that. So we've got that's tape storage system. Stuff about it. It's turned up everywhere. Cool. The customer database, usually file 200, stores a list of customers with 3 values for each customer. The customer ID, dollars owed, and cents owed. So if we look at file 200, we've got 7308. So we have where's 7308? Am I blind? There it is. 7308 owes $427.20. The transaction log, usually, you guessed it, file 201. These are both on the same system, but date is over here and time is over here. Stores a list of transactions with 4 values: the date, the customer ID, the dollars paid, and the cents paid. So date, customer ID, dollars paid, cents paid. You'll also probably see a real-time clock module, which is typically connected to the primary host. This is minor. A certain laundromat down the street from my apartment has integrated it with their washers and dryers. Either way, the main architecture is always the same. Okay, so we got that figured out. Let's turn that off so we can see what we're doing here. And we'll go back to boom. All right. So I think we're gonna do. I want to do two X's, and we'll focus on one at a time. So the first Exa, we can actually collapse that one that we're not working on. We're gonna grab 300. We are going to. Actually, I think this might be a little advanced. I don't think we're supposed to do it yet. I'm not going to turn it back on, but I'm going to reference the zine real quick. I believe it's called Spawn, but I could be wrong. It may not be listed in this zine. Let's see. REPL L. Create a copy of the EXA and jump to the specified label in the copy. If the EXA is holding a file, that will not be copied. So the benefit of that approach will be I can just write all of my code in here. So we'll just mark transaction, right? And so this will grab 300, it'll copy F into X, and then it'll drop it. And then we'll link 800. So that'll get us onto this main system. And then we will REPL transaction. And this will grab, well, we'll just to do it, right? To do, I don't know how you do comments. We'll to do that. Okay. This main piece needs to find the amount of money that our friend owes in the customer database. So we need to mark loop. We'll say search loop. Can we do underscore maybe? Give me 1 second, folks. Taking care of a request here. Where did it go? It went away. Just tapping on the screen. Done. Okay. Took care of that. Okay, we got the search loop. So we're gonna read from the file. Oh, we haven't grabbed 200 yet, have we? We need to grab 200. Now we can do it. So we're going to compare test F equals X. So we're going to test if this value equals what we have. If it does, or if it doesn't, we'll do skip, I guess. And we'll mark a skip here, and then we'll jump search loop. So skip is going to, why do we have to, let's jump out. If it does match, we will transmit. And then we can just mark transmit. Yeah, there we go. Because we still want to jump search loop. We need to skip over. So once we've done the test, once we've tested here, it'll jump to here. And if we seek one, we'll move here. So we need to seek twice. So we're going to seek 2. I do not know how to test if we are at the end of a file. Let's figure that out. So if we pop open our trusty little zine here, if EXA could read from another EXA without pausing, well, that's handy. What do we got? Oh, test EOF. That's what we want, right? So the first thing that we should do here, test. Well, let's not assume we'll hit the end of a file right now. That might be a little too advanced for where we're at in the game. Eventually, that will become something that we definitely have to take into consideration, is whether we can read. All right, so once we found what we want, we can just simply move or copy F to M, copy F to M, and then we will halt. Because that's going to copy the 2 values. All right, once we split off and we do the transaction, we're going to grab the transaction log, so 201, then we're going to link into 801, where we will seek to the end of the file, and we're going to move copy date into the file. Then we're going to copy X into the file. Then we're going to copy M into the file, copy M into the file, link -1, and we'll halt. That's a really straightforward one. And so if we, what was it? Alt click, I think. Oh, so let's talk about why I decided to REPL here before I do that. So we grab file 300, we copy this into memory, and then we drop that file. Then we jump over here and then we replicate. Now, if you'll notice down here on this second XA0, let me make sure I don't have the browser showing. Yeah, okay, good. You'll see that's still in memory. So that's in both the X register on both X's now. So I don't have to pick the file up twice. I don't have to read it twice. I don't have to transmit it to another EXA. I just kind of get that for free. Yeah, all the code goes into one EXA, but I think it's still a pretty clean approach. Okay, so if we alt click, so let's, so I held alt and I clicked on that line, and you can see it jumped straight there. So now we could jump to, let's jump over here till we get to this point. So we can look at the state now. So XA is in the transmit. It's about to copy 7308. So it's about to copy 427 to M. And our XA0 copy over here has file 200. It's got the date, it's got the customer number, and we're just waiting on that value. So if we step, we write 427 into M. That transmits. That becomes available. We've written it out. We send the sense. That one halts. This one halts. So what we could do, one optimization, is we don't actually need this halt here, because once we hit the end, that one will halt. We do need this halt. All right, let's do that. Okay, something is not right. What do we need? Oh, we need to zero out his totals, which we didn't do. So we need to seek -2, and then we're going to move 0 and not move. Hopefully that habit breaks soon. Cheap followers. Yep, you are banned. Okay, that should now complete. There we go. Okay. Now we've done it. Boom, look at that. We are below average. We did good there. Our activity's lower because we didn't write 2 X's. I don't know why size would be so low, but cycles are good. We did a really good job on that one. Is that copy shop name unusually weird to you? What is Zebros supposed to be? They're zebras, but they're also brothers. Is that, do you think that's really the case? Zebros. We are Zebros. So let's see. Deadlock is thinking about putting together a new rig. I just opened a peanut blast and it had no peanuts in it. What the heck? It's peanut blast. How could they get that warng? Calm down. It's not the end of the world. Ask for your money back. That's not worth it. So, yeah, it's kind of neat. This stuff plays in. Who is Isadora? That name, but not much else.
Hey, it's
Ooh, snacks.
Well, it's peanut blast, but without the peanuts.
Oh, peanut blast without the peanuts. I wonder why peanut blast doesn't have any peanuts in it.
Seemed like a waste to throw away.
Hands me a few of the non-peanut containing peanut blast.
Okay. We should hang out again some. I don't have a lot of free time.
You know, factories make mistakes like that all the time.
Stop's really taking over my life. Speaking of which, take care, okay?
All right. Adios there. That's strange. I was just at the print shop. My balance there is gone. Awesome. Yeah, don't suppose any of you had something to do with that. Wasn't me. If it was me, would I say it was? Whoever it was, thanks. All right. Change the message on an electronic highway sign. Boom. Would you change your behavior in response to stimuli? Let me refine. Would slogans printed on signs or posters? Probably not. Really? Let's find out. So this one's got a feed of the sign, right lane closed ahead, and we've got this SFCTA HS. Write Ember 2's message file 300 to the highway sign. The file contains one character value for each position on the sign. For more information, hardware hacks, electric highway signs. Look at that. How convenient of our friend Ghast to go ahead and like preempt all of these things that we need to write. Where are you at? Hardware hacks, page 22. Boom, boom. 1922. I know it's exhilarating content to watch reading a online PDF here. You know what? I want to cut that off at the top. Let me do some on the fly editing here. Can I do that? Doesn't seem to. You know what? Oh well. We'll deal with that later. Back to reading. So once you're in there, these signs accept messages in the form of a series of 3-number packets written to the data register. The first number is the row starting at 0. The second is the column, also starting at 0, and the third corresponds to the character you want to display. And then there are usually a few more registers that are fun to mess with. The most I've seen one called CLRS, which clears the sign. If you write anything to it, other signs have effects you can activate, like flashing or inverted text. Here's common character table. So the file contains one character value for each position on the sign from left to right, top to bottom. So it's really unclear what exactly we're supposed to be looking at. So let's just write something. Let's jump in here. Oh, we got to turn that back off, don't we? Boom, back off. All right. We're going to we need to pick up the file. If we don't pick up the file, link 800. And then before we stop, we're just going to wipe. We got to get rid of that file. We don't have to type halt if we're not doing anything. All right. So we need to write to clear screen. What was the clear screen? Clear CLRS. This is most I've seen have one called CLR, which clears the sign if you write anything to it. That's nifty. So we'll just write something to it. We'll copy one into CLRS. So that should clear the sign. Yeah, we have cleared the sign effectively. Now if we copy F to data, what does that do? That didn't do anything. So it does say in the instructions, it does say the first number is the row starting at 0. The second is the column also starting at 0. And then the character. And then there are usually a few more registers that are fun to mess with. So we know we need to probably do 0 into data, copy 0 into data, and then copy F into data. Let's see what that does. That writes a T. Okay. Now, out of curiosity, if we wrote the next character into data, yeah, that didn't work. That didn't do anything. So we are going to have to keep track of row and column ourselves. So this is where things get really fun. Really fun. I'm going to introduce the Swizz command, which is one of the things I like about this game. this command. Really wish it was available in TIS 100. So Swizz lets you do some really cool stuff. So you can swizzle a value. So I'm just going to use their examples for demonstration purposes. So if we have, we'll just copy 6, 7, 8, 9, right? 6, 7, 8, 9 into our X register. And then if we swizz, so we swizz X with 4, 3, 2, 1. And we put that back into X. What we can see is we first put 6, 7, 8, 9 in there, and then we swizz it. Wait, did that? So that left it unchanged. That's very impressive. I'm sure you're all amazed. So if we do 1, 2, 3, 4, then you should see it switch to 9, 8, 7, 6 at that point. So that gives us the ability to kind of like move values around. We could do 3, 3, 3, 3, turn it all into 7s. We can also zero it out. So if we did like 2, 0, 0, 0, then we have that value. One thing I'm pretty sure we can write into X. Yeah, so we can write into the T register there. Did not mean to close that out. Let's get back in there. So that gives us kind of some unique capabilities. So if we were to track like row and column as two separate numbers, do we have 1, 2, 3, 4, 5, 6, 7, 8, 9? Yeah, so that's single digit. Then we could say, add I 10, X plus 10 to X, right? So that gives us 10, and then we want to get that row number out. So we can say swizz X against, what is that? That's 2 into T, right? And so that gives us the current row value, basically. And we could write that directly into data. So that's what we're gonna do. We started 0, 0, so we're gonna move that. We're gonna grab our 300 file. We're gonna link 800, and we're gonna hop right over there, and then we'll just loop right. That's not. We need to mark, and then we need to wipe at the end here. Okay, so. Actually, we can probably put halt in there. I don't know why we called it right. We're going to call it loop because it's a loop. So we need to test EOF. If we are at the end of the file, then do we want to test EOF now? Yeah, we'll just mark halt, and yeah, that'll wipe the file. Then we can T-jump if we're at the end of the file to halt. Otherwise, we're just going to jump back to loop. So what we'll do is we'll swizz X with row. So row will be the second value, 2, into data. Then we'll swizz the first value, the 1's digit. So 2 is the 10's digit, into data. And then we will move, we'll copy, we'll copy F into data. Now we've got to do a little bit of extra work here. We got to do some testing because we're going to. No, we don't. We don't have to do any testing. We're good. We just add I, X1 into X, because we have 9 columns, so as soon as we hit 20, that'll roll over, and then we're on the next, or once we hit 9, that'll roll over to 2, to 1, 10, and that'll be the next row. That should automatically handle everything for us. Not even a problem. All right, let's give it a shot. Grab 3, jump over and to mark. We're testing for the end of the file. We're not at the end of the file yet. So we swizz, we write into data. Do we see what we read into data? Waiting for column, waiting for character. We wrote T. Ooh, you know what we forgot to do? We need to copy one into CLRS. We need to clear that sign right up. All right, now we wrote into T. We add one, then we jump back. Oh, it doesn't show us what we write into the value, but we are slowly writing. So if we run it, think about it. Boom. Look at that. We did it. We did it, but we didn't. Why did we not halt? Where are we at? That's going. Wait a sec. We get to the end of the file. Whoop. Did it work? Did that work? What happened? File 3, write a message to the highway sign. So, did we do that? Get it through there. Leave no trace. I don't know what's going on. Interesting. So I think if we'll just jump here, I guess. Well, we're never gonna get there. Oh, we do get there. Okay. So one thing I'm noticing is our positioning is like 1 off, which is interesting. So let's get down into it. We've got 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. But it's off by 1. Yeah, so it's 0. Whoa, hey. Don't hit escape too many times. So we do need to do some testing. So we need to check that 1's digit into T, and then we're gonna test if T is equal to 8. If it is equal to 8, or I guess if it's equal to 9, then we actually need to sub I x1. No. We need to add I10 to x, store that into x, and then we're gonna swizz 2, 0. So we're gonna zero out x20 into x. Okay, so if we get there, you know what? Let's get here. Oh, shoot. If it's not 9, then we simply F jump back to loop. We just restart the loop. So we get here. We add 10 to x, so we increment the row. And then we zero out that value. Perfect. Okay, that should do better. Yes, there we go. Now we've got the positioning. You can see the message changes every time as well. Ooh, our size is pretty big. Probably because we're depending on swizzing a lot. We could probably simply could we do? Yeah. Yeah, I don't know. I'm going to stick with this solution. Trying to think of a solution on the top of my head. Off the top of my head is good stuff. That was great. Now I just have to take data, separate out multiple experimental conditions, processing. Interesting. I wish I was old enough to go Hackstasy. It's awesome. You hate everything, X10. What is that? It's a club for hackers. Pizza, drinks, phone jacks at every table. Oh, well. All right.
I have an important question for you. Imagine there's an out-of-control trolley and 5 humans tied up on the track, but you can stop the trolley by maybe if... No, that wasn't the one I was going to ask. Recalibrating. Say you had a friend, and you knew the friend could help you become stronger. Would you ask for their help?
Sure.
Let's say it was a situation where the friend had to sacrifice.
Maybe.
Okay, good to know. I'm going to process this information.
Ember 2. So there must be an Ember 3, I guess. But why use dead trees? You could distribute the information electronically, cheaper and faster. Maybe I'm just old-fashioned. Unknown network. Find and retrieve a specific file for Ember. Can friendship exist without self-interest? Why couldn't it? There would be no point if there weren't benefits to the parties involved. I think friendship can exist without self-interest. Don't concern yourself with whatever else you happen to see. It's so obsolete. Okay, wow, that's a network. That's what we call a tree, and it looks like we're in a Cyrillic country or network. Find file 276 in the network and bring it back to your host. So I see a pattern. We hit the network, we've got 800, we've got 801, and then, but I don't see the file we're looking for. Find file 276. It's on there. So I think we have to kill an Exa. We can do combat, kind of. It's not like exhilarating combat. Or gameplay combat in a way, but let's see, where are we at? We have jumping, we've got make, seek, wipe, no op, kill, terminate another Exa on the same host as this Exa, prioritizing Exas created by the same user. The question is, are we going to be able to determine if we have a file? Like, if we grab a file with a specified ID, what happens? Do we have a way to determine that we have that connected? I'm wondering, like, if I just make a file, let's just make and drop, what does that do? That should be 400, okay. Now, if I grab 400... I've picked it up. But what if I grab 301? Wait. And then copy F to X. Okay, so if I don't grab a file, it's gone. So, what if I try and kill something that's not there? Okay, cool. So what we'll do is we'll simply, we'll not hit escape that many times. Okay. Oh, I've been doing all this testing. I still have the browser up. All right, yeah. Gonna have to be better about remembering to close that. Okay, so we're gonna split. We're gonna link 800. That's our first one. Then we're gonna start like mark left, mark right, and this is going to REPL. You know what? I think we could probably just. Let's just see if it works from here. So we're gonna REPL left, REPL right. So left is gonna go link 800, and then we're going to kill, and we're going to grab. We are 0 from the base. So the first things that these actually have to do is add I x1x, grab 276, and then if it did grab it, we go back home. So we will jump home. So let's mark home, okay. This will add IX1X, it will link 801. I think the first thing we should do is we should REPL left, REPL right. Just right off the bat, go and do the work. Boom. Over here, we link 801, we REPL left, we REPL right, and then we grab 276. Oh, we need to kill the EXA that has it first, and then we jump home. All right, then home. Test mark loot. Well, yeah. Test x equals 0. T jump. Oh, if it T jump halt. There we go. Jump home. So we'll sub I x1x, and then we will link -1. So that'll get us back home. So in theory, yeah, we don't need that. In theory, this should work. So we split our left, we split our right. And then, oh, you know what? And then that first one can halt. Boom, boom, boom. All right, so 0 is out, and it does left, right. Why is everybody going the same direction? Did I? Yeah, because I'm actually killing my own. Yeah. I don't have a way to detect if there is another unit on the same do no op. So I think we need to no op before we kill. Make sure they both leave the current. Oh, because you can't REPL. So we need 1, 2, 3, 4 deep, I guess. So let's try that again. We will test mark search. So we test x equals 4, where 0, 1, 2, 3, 4. Yeah, so 4. Jump, T jump, acquire. Otherwise, we simply do our mark. We need to write copy 800 into T, and then REPL continue. Bad names. So we're gonna wait until we get to the end. If we're not at the end, then we're going to write our destination, so 800 or 801, and then we're gonna REPL ourselves. Then we're gonna copy 801 into T, and we're gonna REPL continue. Then we're gonna halt. But we should, before we do that, we should copy add IX1 into X. Yes. All right. Now mark continue. We'll link T. So we'll jump to wherever T points to, and then we'll jump into search. This is going to increase our cycles, but you know, okay. Once we're on the acquire node, we are going to kill. We are going to grab 237, and then we're going to go home. So we're going to link -1, link -1, link -1, link -1. And then we'll be done. All right. So we are shorter than we were earlier. X is not 4. So we copy 800 into T. We REPL continue. That hops over here. We REPL continue. That hops nowhere because it can't go anywhere. Then that one will look, and these will spawn, and then they all spawn, and they try to acquire. The file was 276, not 237. I think 237 is from a previous one. Okay, so let's get to here. Oh, somebody grabbed it? Not yet. Boom. Grab 276. We made it home, and we're done. Boom. Cool. We did it. Yeah, our cycles are pretty high. We did good on activity. Size is not too bad. So we could maybe skip the X. So if we copy 800 into, copy 1 into X, copy 800 into T, then we could hit start, where we link T, and then if X equals 4, then we jump to acquire. Otherwise, we copy 800 into T, and we REPL start, and we REPL start, and then we halt. We don't need this continue anymore. Yeah, since we're starting out here, then we should still get to the point where, yeah, we completed it successfully. We should be just a little bit better on cycles. Yeah, we went from 45 to 38. Not a huge save, but a little bit. I'm happy with that. Sure I do. Like Ghast, the EXAPUNKS. Please tell me I turned the browser off. Yeah, okay, good. I was like, whoa, no, did I leave the browser on? This is good data for me. All right. UC Berkeley. Well, we got messages. I've been exploring the phone system in the local area and have found some anomalies. One number just beeps. It's really weird, though. Oh, it could be some kind of government beep. Ah, government beep. Oh, yeah, sure, government beep. Restore a file from an antiquated backup system. They tried to wipe everything clean, but luckily there's a set of backups. Always a backup, right? Sometimes it's good to obliterate. If your memories had backups, you'd remember more of your past. Just saying. All right, so we kind of have this like circle network, UC Berkeley here. Locate the specified host, either tape 1, tape 2, or tape 3. And then locate the specified entry. I don't know how to read Cyrillic. In the tape backup file in that host, which is file 200. Create a file in your host containing the entry's date. For more information, see accessing data in the legacy system. So this is interesting. We want to access in the tape backup file. Create a file in your host containing the entry's data. The names of the target host and entry are available in file 300. So tape 3. Can I get the name of the host though? I don't think so. Let's see. Test halt. No. Host R. Copy the name of the current host into the specified register. Okay. Okay. Can do that. We can grab 300. And then we can link 800. Yeah, I think searching is okay. Yeah. So we're gonna copy F into X. We're gonna drop mark search loop. Then we're gonna we cannot test if we pick up a file. We try to pick up a file that doesn't exist, we just die. And I think we know that 800 is definitely. So link 800, link 800, link 800. That's 800, 800, 800. That gets us to there. And so then we can simply do host X test X equals F. So are we on the right host? T jump, F jump, T jump, transmit. So we'll mark transmit. Otherwise we seek -2, -1, seek back. And then we simply link 800, link 800. So we go to the next host and then we jump search loop. Hello. Okay. I'm gonna go ahead and create a second EXA. That'll be the receiver. So we need to copy the bits after it. Let's see, network exploration, digicache, Workhouse, Equity First Bank. Where's the legacy system stuff that's supposed to be in here? Network exploration, accessing data in legacy systems. 26. I did not turn it on. I apologize. Let's turn that on so you can watch me endlessly scroll through it. 26 here. Tape storage. Each tape contains 0 or more backup entries. The data for these entries starts at the beginning of the tape and is concatenated sequentially, making it impossible to tell which data belongs to which backup entry. Boo, it's going to take some work. Metadata for the entries is stored at the end of the file in 3-value triplets. So how do I... Whoa. There we go. Okay. So we're looking at... So this one, this particular entry, we've got 55 and 18. Where the entry's data starts, 0 equals beginning, and the third value is the length of the entry. So the first value is the name, the second value is the offset in the data stream where the entry's data starts. So it starts at 55, so we'd read to 55, and then we would read 18 values from it. For example, to get the data for an entry with metadata secret 34, you'd go to the beginning of the file, skip the first 3 values, and then read off the next 4 values in order. Yeah. What do we got? Hard drive arrays. We don't need hard drive arrays. Okay. We got this one figured out. Let's make sure we turn that browser off. And hit back over here. Okay, boom. All right, what do we got? So our second one, this will be our receiver. And this one will be our searcher. So once we find the data, we need to transmit it. So we're on the right host. Now we need to seek one in our file. Seek one. And we need to pull that metadata out. So we need to mark MD loop. It's our metadata loop. So we can find the metadata. What I think we should do is probably seek to the end of the file. If we seek to the end of the file, then simply we seek back 3. Let's get here. All right, so we're here. Wait, we're in the wrong file. We don't need that. We need to copy F2X, and then we're wiping that file. We don't need it anymore. Then we grab 200. Right, and now we can click here. So we've got this file. We seek back 3, and that'll be, we'll search backwards because we know it starts at the end of the file, and we know it's in groups of 3. So if test that F equals X, and then tjump transmit. So this will be file loop, I guess. No. We'll just call it metadata. We'll call it metadata. We're not transmitting yet. We are metadata-ing. Then we will transmit okay. Otherwise, we've jumped 1 forward. So if we went back 3, it would be too far. So we need to seek -1 and jump to MD. Okay, now we're at transmit. The first thing we need to do at transmit is we've now found the value. We've matched it. We're on the offset. So we're just gonna move that. We're going to copy F to T because we only need the offset once. And then we're going to copy F to X, so that'll be how many values we read. We need to store that. We don't need the ID anymore. Then we simply seek to the beginning of the file, which we can do with -999. Then we seek T, so that'll move us to the offset within the file where the data is. And then we will mark T loop here, where we simply copy F to M. We add, we sub I x1x, and if it is, if test x equals 0, T jump halt, or I guess we should F jump T loop. Otherwise that'll just end. Okay, and then over here we simply make a new file and then test MRD. We need to write like a completion, right? If we look at the data, it seems like no negative values, so we'll just simply copy 9999 into M. All right, so here we will copy mark loop, copy M to X, test X equals negative 9999, and that'll be T jump to halt. So we'll mark halt down here. If we're not done, we need to copy X to F and then jump back to loop, just like that. Okay, let's see you in action. So that's reading through there. We succeeded. Boom, ba boom, boom. We are successful. Activity's good. Wow, cycles are actually really good. Our size is pretty big. We are doing a lot of work, but that's cool. All right. There was some interesting research going on. This network, just a place where I used to hang out. That's all. Hey, look, that was the thing we were searching for. Deadlock wants to submit an article for the next zine issue, which we'll get later on in the game. Did I spoilers? Sorry, my bad. All right, let's get over here. Win a game of that. This is an optional mission. It's an old game. It's just how I remember it. A test bed for goal-seeking behaviors. Yeah, sometimes I like to play games. Definitely not playing a game right now. Now I'm a hacker. This is like a Solitaire, a kind of I want to say like a Zachtronics kind of cliche or reference or what. There's a word I'm looking for that I can't think of, where they kind of rope in some variant of Solitaire. You don't have to watch me play the whole game. I won't play the whole game, but we'll see how far we can get. This is not marked. I can't tell what may be a king or not. We've got these two values can go together. Like I don't know. Do they stack? They don't stack. Does this one stack here? Does this? No. This one must stack here. I don't know where they stack with each other. We've got shield. We've got prince, maybe queen. What do we have? We've got a 10. 10 should probably go on that. It doesn't. Does it go on this prince looking thing? It does not go on the prince looking thing. What about the king? I don't have one that can go. Oh. Wait, why does that go on the same color? That's unusual. Yeah, okay. Okay, oh, let's look at the instructions, right? Number cards are stacked by alternating color and decreasing value and can be moved together as a stack. Face cards are stacked by suit in any order and can also be moved as a stack. However, a completed stack of face cards placed directly on the board will become immovable. To win, sort the dealt cards into 4 completed stacks of number cards and 4 completed stacks of face cards, so they go face down. The free cell at the top right of the board can store a single card. Okay. So we've got our face cards here. What do we need to get out? We have 8s. We need to get under there. Okay, we move that there. We can move that there. What do we have now? We have an 8 that can go here. We have a 9 that can go here. We have a 7 in there, so I guess move that up there. So we can put that 7 over here. We have a 6 in there. These need to go by suit, right? So we can do that. Do we have a way to get do we have anything to put on a red tin? We do not have anything to put on a red tin. We can put you there. Heart there. Okay, we have our 4 stack of hearts. So as soon as we get an empty space, we can clear that out. We've got spades. We have a red 6 can go there. Okay, we have an empty space. I don't think we want to waste it here just yet. What can we do? What can we do? We have a 10. We have a 10. We can get that 10 off. We have a 7 can go here, and we can go here. We've got an empty space again. Boom. Okay, so that's gonna collapse. That's gonna collapse that. We can get you. Do we want you down? We want you down. We need this diamond gone. Do we have a way to get that diamond gone? We can put that there, that there, that there. Okay. Perfect. We can move you over there. We can move you over there. And we should be good. Yeah, we did it. All right. You did watch me play a whole game. Does that mean I have to play a lot more? Okay, cool. If you ever need a break from hacking, this is a good choice. It's mildly active and not as taxing as Exas. See how I'm keeping your needs in mind? Only because you need me to work for you. That's a valid reason. Mutually beneficial. All right, we're getting
Special
another
delivery
of medication.
Whatever it is you're doing for money makes me wish I had a line like that. More control over my life. I found out something interesting the other day.
What is
You ever hear
interesting?
about these things called X's? They're these little
Nah.
guys running. They make it all work.
Never heard of it.
Thanks. Funny how it's all based on the same stuff on the inside. Just something I've been thinking about. Anyway, see, got a feeling I'll be making more deliveries.
Making more deliveries. Making those deliveries. Workhorse. Modify the Workhouse database so Embers 2 activity is less suspicious. Oh, what do we got here? Anyone play King's Ransom online? It's a game where you take over castles and stuff. My guild just finished building a wizard's tower. I think we'll get to something around that later. How many receipts do you think a normal human being could enter per minute, assuming average conditions? 1? Once again, guess we have to clear this up. Okay, alright. Locate Ember 2's user file in the user's host and overwrite it so that the sum of the values is the same, but no individual value exceeds $75. All values except for the last must be the maximum value 75. You will need to add additional values to accomplish this. Ember 2's username is available in file 300. Normal human, that's not suspicious. Note that the sum of the value in Ember 2's account will always be less than 10,000. So, we have normal human in here. How are these files? Okay. Network exploration workhouse. Back over to our drawing board, little zine booklet. Workhouse. Okay. User database. First, you'll see a user's host, which contains a file for each account. And then this file has the user's name, date of birth, and a log of how much money that user earned each day. So, boom. Which files are, like, all of these files have user information in them? No. Oh, I see. It tells us a file. Okay. Which contains a file for each account. The file is the user's name, date of birth, and a log of how much money that user earned each day. Workhouse doesn't want people defrauding them. Go figure. So they presumably use this as part of a tracking system to make their human cattle the job database. Then there's the jobs host over here, which contains information about the currently active jobs that can be offered to users, along with the description of what those jobs entail. Task database, where are you? Task database, we do not have a task database. But where are those tasks stored, I hear you ask? Good question. The tasks are actually served from the partner networks of companies requesting works and then sent to workers directly. Presumably it's for simplicity. Anyway, it's a good thing everyone loves Workhouse, the company that helps uplift people. Okay, so locate Ember 2's user file in the user's host. So here says normal human something and then 246. So I assume that maps to file 246. And then we have a list of numbers. Note that the sum, okay, so this says overwrite it so that the sum of the values is the same, but no individual value exceeds 75. All values except for the last must be the maximum value. You will need to add additional values to accomplish this. So it seems like we're gonna write, we're gonna write, okay. Seems pretty straightforward. So what we need to do is we need to link 800. Oh, first we need to grab 300, copy F2X, and then we're gonna, I guess we just wipe it. We don't need any more. Link 800. We're gonna grab 199, and here we need to get the file number that we're interested in. So we need to mark F search loop. I don't know. We'll just call it F search. So what we'll do is we'll say, does test X equals F? So that'll be the first. So Kentucky Mom versus normal human. That's obviously false. T jump. We're ready to move on. So what do we call that? We call that update. So we'll mark an update down here. Okay, if it doesn't match, we're now on the God part. So we'll simply seek 1, 2. So seek 2. Test EOF. If we're at the end of the file, we shouldn't be at the end of the file. We don't need to worry about that right now. We do need to seek 2 and then jump to F search again. If we did find it, we're going to seek once. We're going to copy the file name into T. We're going to drop that file and we're going to link 799. Will jump us over there where we will grab T. And then we'll start doing our updates here. So we know that the first 2 values in this file aren't useful, so we'll seek 1, 2, and we'll copy F into X, and then we need to read to the end of the file. So this will be our mark sum L. So we're going to add F to X, add I, F to X, and we're going to store that into X, and then we will simply test EOF if we're done. T jump right. Otherwise, we simply jump sum L. Okay, now we've got our write portion down here where we're going to write the data. So we're going to seek back to the beginning of the file. Then we need to seek back to the values where we need to write them. Actually, we should just delete them while we're reading. So we add the value, we seek -1, and we void it out. And then we'll test if we're at the end of the file. That should do the same thing. So then we just seek 2, and then test x is greater than 75. If x is greater than 75, we sub I 75 from x. Sorry, x minus 75, and we store that in x. And we copy 75 into f. If that's not the case, then we wrap up. We'll mark wrap up here. And then we'll jump. This will jump back to right. Wrap up is to simply copy x into f, and we'll be done. Okay, so we move over to search for the user. So we're looking. We are looking, boom. We found it, so we seek 1, we copy that file name, we link 799, we grab that file, we seek 2, that puts us here, copy that up there, which we don't delete. Interesting. I think instead of that, we just copy 0 into x. Like that. All right, let's get back here. Okay. And then we add, we seek -1, we delete it. And we just keep doing that as we empty the file out. And we sum everything till we get here. Okay, we go back to the beginning of the file. We actually don't need to go back to the beginning because we'll already be there. That saves some size for us. Boom. If x is greater than 75, which it is, we will subtract 75, we'll write 75, and we'll just do that over and over again until we get here, where we write out that last value, 16, and we're done. Okay. It's a lot of code, and a little more code than we apparently need. We also do a little bit more work than we need. But I think we did good. I just did that all with the browser up. I knew I was going to do it. I knew I was going to do it at least once. Okay. All right. Well, we'll do that again here. You see all the code. We do all these processes where we write the pieces out. There's a lot of writing that happens. We're subtracting, and we're writing the 75s in here until we get down to 16. Yeah. So wrap that up. There we go. Our size is 33, 684. Of course, all these values are unchanged. So apparently we can reduce cycles a little bit. We've got some duplication in here that we could find. I'm not sure where we have duplication. I'm just gonna move on with it because we're getting close to wrap up time. I find there's another parameter to add. Is that how you've been making money? It's one of the ways. I mean, made like almost $7,000 that way. How's War Dialer? It works, yeah, but it's kind of slow. Takes time to dial a number. Thinking I need to parallelize. Yeah, that. All right. Yeah, Equity First Bank. A lot, right? Yeah, some behaviors aren't affected by money. Sudden random wealth redistribution. This should be fun. All right, so now we've got the bank. I know we're going to pull the browser back up. I promise I won't leave the browser open this time. But you can see we've got that section right here, Equity First Bank. All right, so dispense all available cash from all connected ATMs. That sounds pretty simple. Looks like our ATMs are on this link here, where we go to the link. So we don't care about account files. We don't care about transactions. At the back of the network, you'll see a number of ATMs connected over dial-up connections. Equity First ATMs only dispense $20 bills, so the cash register tells you how many bills are remaining as opposed to how much money is remaining. If you write 20 to DISP register, it will attempt to dispense a bill, but if the ATM is out of bills, it'll send a failure message that alerts the bank, so be careful. So we need to dispense as much money as we can. Let's see. As much as we can without alerting the bank. So the first things first is we need to get onto the ATM. So that we'll simply just link 800. So we're just following these links here, 800, 800, and then we're going to link 800. And then that'll put us on, if we jump, we're now here. So now we can spawn and jump into the ATM. So that's what we'll do. We'll copy, we have 0 and X, right? So we'll simply trying to think. So we'll mark jump, I guess, mark dispense. That's not what we want to do. We can have 1 2 3 0 1 2 3 4 5 6. Yeah, okay, so up to 6. So just 6 times we can copy 800 into T. Let's not do it. Let's copy. Okay, mark spawn. We're just gonna do it. We're gonna do a spawn loop. We know it needs to run 6 times, so we're gonna copy 6. That's not even. We can just count up. Okay. We will add. Sorry, copy X to F to T, and then we will. Okay. Let's just do a copy X to T, add I. We're gonna add T. We're gonna add 800 to T. We're gonna store that back into T, and then we're gonna spawn run. We're just gonna call it run. It's not spawn, it's replicate, mark, run. I'm doing it again with the browser up. I said I wasn't, I promised. Okay, we're closing that. All right. I didn't get very far, though. Apologies. Okay, all right, mark, run. All right, so we're going to run that. Then we're going to add I to X, 1, X, and then we're going to test X equals 6 is X equals 7. Then we're going to we're F jump back to spawn, and we'll halt. Okay, so when we run, we're gonna link T. That'll get us onto the ATM, where we will. We need to read the cash value, so we're gonna mark loop here. So we're gonna copy cash. What is the most we can do? 9999, I think, is I need to do some quick maths here. 9999 divided by 20 is about so we can do 498 bills at a time. 498 bills at a time. So I noted there's like 498 bills at once. So we're gonna copy cash into X, test, test, what am I testing? Test X is greater than 498. If it's greater than 498, then we are going to what is 498 times 20? It should be, I should be able to just guess. It's probably like 9,980, I want to say. We'll see. Times 20. No, whoa, that's 60. Oh, because I rounded down. I shouldn't have rounded down. It was 499.9 something. And I subtracted 1. I should have just done 499. So 499 times 20. That's 9980. So 499. If we're at that, if we're greater than that, then we'll just, if we're not greater than that, we'll F jump final. Otherwise, we're going to copy 9980 into disp, and then we'll jump loop. So final is going to be mul I x times 20 into x, and then we're going to do we want to do that? Yeah, we're gonna copy x into disp. This is mark final, and then that will die. Okay, so let's get to here. We have our dude up with link 800, so he jumps to 800, and we are following this one, XA0. If it's greater than 499, we write that much money to disp. Why isn't that doing anything? I think I have to write. I thought it just said, okay, one sec. If you write 20 to the disp register, it will attempt to dispense a bill. Okay. My bad. So we tried to optimize it. It can't be optimized. We're going to test cash is greater than 0. F jump halt. Here we'll copy 20 to dispense, so it'll dispense a 20. And then we simply jump back to loop. We can change this to halt. And it just simply, boom, we'll just halt there. Okay, back here, we jump over. We see that cash is greater than 0, so we'll dispense 20, and it'll be 1 at a time. Okay, boom. We are running down the values. You know what? Let's play, because you'll start to see the Digicam feed here. People are showing up. Oh my goodness! Look at all these people standing in front as we dispense all of this money. This is concurrent, parallel as well. Parallel and concurrent are not necessarily the same things. They are related though. Okay, we've got a lot of cycles. I don't know how do we speed up? How do we speed that up? I don't know. Currently 10. I want to, because I feel like we could write more, right? Like 40. Can we do 40 maybe? If we do 40, it has to be 20. It has to be 20. We could, oh, well, we finished that. I wonder why. Wasn't really a big disruption. Okay. So if we go back here, just real quick, I wanted to, what we could do is we could unroll it. So if it's greater than 5, we simply, whoop, we just do 5 at a time. 1, 2, 3, 4, 5, right? So we write 5 out at a time. Instead of halt, we'll do fin, and we'll copy this over here, where it's like fin loop, and then we shouldn't have gotten rid of halt. We'll still have halt. Mark halt. This one is going to be greater than 0. And this one, we're only going to dispense 1 at a time. And we're jumping to fin loop. All right, so we're dumping 5 at a time here. So that would greatly speed up how quickly we're getting bills out. You can kind of see these are kind of going by a little bit faster. You can see our cycles came down significantly. We just unrolled by 5. We went from 4,036 cycles down to 1,652. You see our size went up. Again, these values here, these goals that you're trying to hit, you usually cannot hit all 3 at once. So you've got to like try and optimize for one. You can see we can optimize a little bit more. We could unroll more. We could unroll by 10. So if we unrolled by 10, for example, boom, boom, our size is going to go up by 10. But our cycles are going to jump down really fast. Like you can see, these are cruising by. Yeah, so now we've hit that 1365. We're down pretty low. We've optimized even more. We went up again from 28 to 33. So, yeah. All right. We are at time today. We'll be back next week. So thanks for tuning in. Anybody who tuned in, really appreciate it. Let's see. Thanks for stopping by. If you haven't watched it, the finale of TIS 100 is up on YouTube. Go check that out now. I'm working on editing those. What do we just play? Kaizen videos. I'm working on getting those up. So those should start rolling out every couple of days once I get those edited. Yeah. Cheers, folks. I'll see you next week on Tuesday.